Exercise 1.2. Prove that root 5 is irrational. Let root 5 is rational, then root 5 can be right in the form of a by b, where b not equal to 0 and a and b are coprimes and integers. So we have root 5 is equal to a by b, and squaring both sides we get 5 is equal to a square by b square. Taking b square to other side of the equal, we got 5 into b square equal to a square. That is 5 divides a square. If 5 divides a square, which implies 5 divides a. That is, a can be written as a multiple of 5. Let 5 into c equal to a, where c is an integer. Squaring both sides, we got 25 into c square equal to a square. This value of a square can be substituted in the first equation. 5 into b square equal to 25 into c square. From this we get b squared equal to 25 by 5 into c square. That is b squared equal to 5 into c square, which implies 5 divides b square, that is 5 divides b. So we got 5 divides a and 5 divides b. That is, 5 is a common fraction factor in a and b, but we have assumed that a and b are coprimes. So it is a contradiction to our assumption that root 5 is rational. So we got the answer, root 5 is irrational. Next question, prove that 3 plus 2 root 5 is irrational. For that, we assume the contrary. Let 3 plus 2 root 5 is rational. Then it can be written in the form a by b, where a and b are integers, b not equal to 0, and a and b are coprimes. We got 2 into root 5 is equal to a by b minus 3. That is equal to, cross multiply, we got a minus 3b by b, where b not equal to 0, and we get root 5 is a form of p by q, where q not equal to 0. That implies root 5 is rational. But we have already proved that root 5 is irrational. This is a contradiction we got because of our wrong assumption that uh, 3 plus 2 root 5 is rational. Therefore, we can conclude that 3 plus 2 root 5 is irrational. Next question, prove that the following are irrationals. First one is 1 by root 2. In the same way, let us assume that 1 by root 2 is rational. Then it can be written as a by b form, where a and b are coprimes and b not equal to 0. Therefore, we get 1 by root 2 is equal to a by b. To prove the contradiction, we can arrange the numbers so that we get an equation for root 2. First, we get 1 is equal to a into root 2 by b. Then b to the other side, we get b is equal to a into root 2. Then a to other side, we get root 2 is equal to b by a, where a and b are integers. It shows that root 2 is a rational number, but we have already proved that root 2 is irrational. This is a contradiction because of our wrong assumption that 1 by root 2 is rational. Therefore, we can conclude that 1 by root 2 is irrational. Second question, 7 into root 5. So we can assume that 7 into root 5 is a rational number. Then we can write 7 into root 5 in the form a by b, where a and b are integers, and b not equal to 0. So we got root 5 is equal to a by 7b. Since a and b are integers, we can say that root 5 is rational, but we have already proved that root 5 is irrational, which contradict our assumption that 7 into root 5 is rational. Therefore, 7 into root 5 is irrational. 6 plus root 2. Assume that 6 plus root 2 is rational. Then we can write 6 plus root 2 is equal to a by b form, where a and b are integers and b not equal to 0. Therefore, we got root 2 is equal to a by b minus 6. That is equal to a minus 6b divided by b, and since a and b are integers and b not equal to 0, this shows that root 2 is rational. So, which is a contradiction that root 2 is irrational. So, our assumption is wrong. Therefore, 6 into root 2 is irrational.